Do you know why your foam cracks, collapses, or feels too hard? The problem might come from your raw materials. Let's walk through 8 key factors that affect foam quality. First, polyether. Polyether reacts with isocyanates to form urethane bonds, which build the foam's main structure. When molecular weight increases while functionality stays the same, the foam becomes more elastic, stronger, and has better stretch. However, its reactivity slightly decreases. When the equivalent value stays the same, increasing functionality speeds up the reaction, increases crosslinking, and makes the foam harder but less stretchable. The average functionality of the polyol should be above 2.5. If it's too low, the foam won't recover well after compression. If you add too much polyether, other raw materials like TDI, water, or catalysts get reduced, which can cause cracks or collapse. Too little polyether makes the foam harder, with poor elasticity and uncomfortable feel. Second, blowing agent. For foam blocks over 21 kilograms per cubic meter, we usually use only water as the blowing agent. In low-density or ultra-soft formulas, we can add physical blowing agents like methylene chloride or MC to assist. Physical agents lower density and hardness. Since they evaporate and absorb heat, they also help prevent core scorching, but slow down curing. To compensate, more catalyst is needed. Water also reacts with isocyanate to form urea and release coal and heat. This is a chain-extending reaction. You can calculate the foam index using this formula. Foam index equals amount of water plus amount of MC divided by 9. More water means lower foam density and higher hardness, but also weaker foam cell walls, making it easier to collapse or crack. TDI consumption also rises, and too much heat may burn the foam core. If the water content goes above 5 parts, you should add a physical agent like MC to absorb some of that heat. Less water increases foam density and allows you to reduce catalyst accordingly. MC is generally limited to 15 parts per 100 parts of polyether. Too much can delay curing. Third, TDI toluene. This flexible pool foam usually uses TDI 80/20, a mix of 2,4 and 2,6 isomers. Pure 2,4 TDI, known as T100, can be made by cooling. You can calculate the TDI amount with this formula: 8.68 plus water multiplied by 9.67, then all multiplied by the TDI index. The typical index is between 110 and 120. Raising the index increases hardness, but only up to a point. Beyond that, tear strength, tensile strength, and elongation drop. The foam may develop large bubbles, become more closed cell, lose rebound, and take longer to cure. The surface may stay sticky for longer, and the core can scorch. If the index is too low, the foam may crack, with poor rebound and strength, greater permanent deformation, and a damp surface. Fourth, catalyst. Amines like A3,3 promote the reaction between isocyanates and water. They help control density and the cell structure. Too much amine causes internal cracks and visible bubbles. Too little leads to shrinkage, closed cells, and thicker bottoms in foam blocks. Tin catalysts like stannous octanoate, Tin9 and Tin19 boost the gel reaction between isocyanate and hydroxyl or urea groups. Too much tin causes fast gelation, poor rebound, high viscosity, and closed cells. Too little leads to poor curing and cracks around the edges or top. Reducing amine or increasing tin can help reinforce foam walls when gas is released, reducing hollow spots or splitting. Fifth, foam stabilizers. Stabilizers like silicone oils prevent bubbles from merging during mid-foaming. Too much makes the cells very fine and leads to closed cells. Too little leads to large pores, foam collapse, and poor structure after rising. Sixth, temperature. As the temperature of raw materials increases, the reaction speeds up. This can be dangerous in sensitive formulas, potentially causing coal burn or even fire. Keep the temperatures of both polyol and isocyanate steady. Even with the same formulation and raw material temperature, summer's higher ambient heat makes the reaction faster. This results in lower density and hardness, but greater elongation and strength. To maintain proper hardness, slightly increase the TDI index during summer. 7. Air humidity. High humidity introduces more water into the foam through the air. This reacts with isocyanate, lowering hardness. Slightly increasing TDI can help, but if humidity is too high, it may overheat the foam and cause core burning. 8. Atmospheric pressure. At high altitudes with lower pressure, foam expands more. Even with the same formula, the final foam will have a lower density. If you found this helpful, don't forget to subscribe to our channel. You can also leave a comment or check out our official website, linked in the comments. We're here to help you make better foam.